This video is on exponentials and logs and seeing that they are inverses. So our first one, we have our exponential function. We have a base to a power equals a number, b to the p equals n. If we want to switch it to its inverse form, we write the word log. We have a subscript b for the base. The number, you can put this number in parentheses. It is a normal number, and it equals p. What I need you to understand is that the b from the base and the n are not being multiplied. There is no operation between the two forms. So how to read this properly, you say log base b of n equals p. Now there are some special cases. So if you notice, if we have 10 to the x equals a number, this is known as the common log. And we don't like to write a base 10. Our calculators are base 10. Most things we do are a base 10. So when it is a base 10, meaning 10's the base, we do not write it in log form. So we just have log of the number equals x. It is assumed when there is nothing in the spot of b, so nothing written right here, it is a base 10. We have one more special one. We learned about the number e. E to a power equals a number. E, if you look at your calculator, the button we press to get E is second and then that ln. So E goes with the natural log. I like to use a cursive L. You can use a capital LN. It really doesn't matter. Of a number, and it equals the power. These are exactly the same. You want to put parentheses around that N, you can. You do not have to until we get to graphing. So we're going to use these three formulas to help us graph. So you need to know these. They work, doesn't matter the order. This is known as the natural log. At the last one. Okay, you need to know these. You need to have these memorized. These come up all the time. Solving, graphing, evaluating, everything. So we're going to start off by just switching to log form. We have all these exponentials. All we're doing is rewriting to the other form. So I have 3 to the 5th equals 243. So I write log. The base is 3. The number that's not the power is 243, and it equals the power of 5. Looking at the second one, we have 25 equals 5 squared. Again, you write log if you're going to log form. The base is 5. The number that's not the power is 25, and then it is equal to the power. This one, we have 10 to the 4th equals 10,000. We just write log. It's base 10, so you do not have to write the base. Of 10,000 equals the power. Again, you do not have to write the base when it's base 10. Number 4, 6 to the negative first power equals 1/6. So log base 6 of 1/6 equals -1. And then the last one, e squared equals 7.39. Because it's e, we have to use the natural log of 7.39, and it equals 2. Done. That's it. Switching to log form. Now, on the next examples, we're going to switch to the other form. So we have log base 9 of 9 equals 1. The base is 9. The power is 1. It equals 9. So base, power, number. Done. Log base 2 of 512 equals 9. Base, power, number. So my base is 2 to the 9th power equals 512. If I were to type that into the calculator, I would get 512. Number 3, log of 100 equals 2. Notice, no base is written. It is a base 10. Base, power, number. 10 squared equals 100. Yes, that makes sense because 10 squared does equal 100. Last but not least, the natural log, oops, I changed the page. The natural log of 20.09 equals 3. Since we're using the natural log, automatically goes with e power number e cubed equals 20.09. That's all there is to switching back and forth. Now, on the next one, we do need to know change of base. Change of base is what we do to type it in the calculator. Our calculators are only base 10, so we have to change it from whatever base we're given to a base 10. The only time we do not use a change of base is with the natural log and the common log because they are represented on the calculator. So, change of base. If I have log base b of n, I do log of the number divided by log of the base. Log of the number divided by log of the base. So here's an example. I have log base 3 of 27. Log of the number divided by log of the base. So if we wanted to evaluate and type it into our calculator, we type it into our calculator. Some calculators require you to type in the number first, then hit log. Some you type in log, it opens parentheses, and you type in the number. Make sure you close the parentheses. You have to press log twice. So 27 log divided by 3 log equals a nice pretty number 3. They're not always going to be pretty numbers. It's okay. So I have a few examples I want you to try. Again, pause it. Try it on your own. See how you do. But I'm going to go ahead and work them out. So we have log of the number, which is 125, divided by log of the base, which is 5. You type it in your handy dandy calculator. So 125 log divided by 5 log. Should get a nice pretty number of 3. And it's as easy as that. The next one, log of the number divided by log of the base. To get the 1/5, it's just 1 divided by 5. Make sure you hit equal so you get that 0.2 as a decimal. Okay, and then log divided by 5 log equals -1. Okay, notice example 3 is something you can just type into the calculator. You just press log and 25 or 25 log depending on your calculator. It's not a nice pretty number. So let's round to 3 decimal places. We have 1.3. Oops, I lost it all. 1.3. Oh, my tablet decides to act up at the end. 1.398. Okay, there was 7/9, the 9 rounded it up. Okay, the natural log of 4, you have a ln button on your calculator. You just type in 4 ln or ln4. You get about 1.386. Okay, so that's how we use our calculator to do or to evaluate logs. This is super important for graphing, for solving equations, everything.